And why do we believe that light-based printing is the way to go? Because with, for example, this technology to photon polymerization, this laser-based high-resolution printing technology, you can print down to subcellular dimensions. We can print down to 1 micron, even in the presence of living cells. So that's one thing why we believe light is the future. The second thing, also already mentioned by Ricardo, is scalability. Speed is just a lot faster in comparison to the other technologies, and a lot more reproducible. So on our quest to make this biofabrication technology turnkey, the materials is one thing, but also the materials, they need to act very well with the hardware. So therefore, we also partner up with different companies, different printing companies like UpNano and Nanoscribe, market leaders in the field of 2-photon polymerization equipment. Regima 3D, Felix printers, extrusion manufacturers. Purdyne also making extrusion print heads. And then more recently, Karel wrote one of the biggest gelatin, biggest chemical suppliers in the world. So that's downstream, but upstream it's also very important because, as I mentioned, standardization is key. So we also have a close partnership with Rousselot, the biggest manufacturer of gelatin. And because we have these collaborations with Rousselot, raw material suppliers of gelatin, and on the other hand, the printing hardware, this further builds on our vision to make the technology plug and print. So making it as easy as putting the materials in the printer, putting your cells in there, and start printing. And we have a few different materials in this respect. So different printing technologies, and I will just highlight some of our exciting materials. One of them for digital light projection, so light-based printing, again, is the Gresings. This is a polyester, very biocompatible. You can see it cells on there, and here you can actually appreciate the resolution you can obtain, as you can see that you can see the individual pixels of the projector and the cells growing on top of it. But what's really interesting on this material is that it has shape memory properties. So actually what you can do is you can 3D print a complicated shape. You can then heat it up, deform the shape, and as long as you keep it below body temperature, it will maintain this temporary shape. So as you can see here, if we dip it in 5-degree water, nothing really happens. But if you take it up to body temperature, it goes back to the originally 3D printed, more complicated shape, which makes it interesting for implantation approaches, where you would, for example, want something to unfold upon body temperature.